Next problem, a random process x of t is given by x of t is equal to a cos alpha t plus b sin alpha t, where a and b are independent random variable with mean 0, variance sigma square. Show that x of t is a WSS. Find the power spectral density of the process. Given x of t is equal to a cos alpha t plus b sin alpha t, equation number 1. Given a and b are independent random variable with mean 0 and variance sigma square. That means mean is nothing but expected value of that random variable. So E of A which is equal to E of B which is equal to 0, and variance of A which is equal to variance of B which is equal to sigma square, equation number 2. A and B are independent. Expected value of A into B which is equal to expected value of A into expected value of B, that is 0. That is equation number 3. To prove x of t is a WSS, that is to prove that mean expected value of x of t is equal to a constant. Now we need to find the expected value of x of t. So expected value of x of t which is equal to expected value of, from 1 we can replace x of t as a cos alpha t plus b sin alpha t. Since a and b are random variable, so cos alpha t and sin alpha t are constants with respect to the expectation. So we are taking those things from outside the expectation. So cos alpha t expected value of a plus sin alpha t expected value of a, sorry, expected value of b. So 0 from 2 we know expected value of a is equal to expected value of b equal to 0. So expected value of x of t is equal to 0, a constant, say Roman letter 1. Now to find Rxx of tau, so we need to prove Rxx of tau is a function of tau. Now Rxx of tau is equal to expected value of x of t into x of t plus tau. So using 1 we can replace x of t as a cos alpha t plus b sin alpha t, and x of t plus tau as a cos alpha t plus tau. Instead of t we are replacing t plus tau plus b sin alpha t plus tau. So multiplying each and every terms, so first bracket first term, second bracket first term, so a into a square cos alpha t plus tau. Then first bracket second term, second bracket second term, b into b square sin alpha t plus tau. First bracket first term, second bracket second term, ab cos alpha t sin t plus tau. Then first bracket second term, second bracket first term, ba sin alpha t cos alpha t plus tau. Again a and b are random variable, and cos alpha t plus tau, sin alpha t plus tau are all constant. We are taking those things outside from the expectation. So we will get cos alpha t plus tau expected value of a square plus sin alpha t plus tau expected value of b square plus cos alpha t sin alpha t plus tau plus sin alpha t cos alpha t plus tau expected value of ab. We know from 2 and 3 the value of expected value of a square equal to expected value of b square is equal to sigma square, and expected value of ab equal to 0. Substituting those values you will get sigma square cos alpha t plus tau plus sigma square sin alpha t plus tau, then the third one into 0. So third term become vanishes. So sigma square common. So take it outside. Sigma square cos alpha t plus tau plus sin alpha t plus tau. Using the formula cos a cos b sin b which is equal to cos a minus b. Here a is nothing but t plus tau, b equal to t. We will get cos alpha t plus tau minus t into sigma square. Minus t plus t get cancelled. You will get sigma square cos alpha tau, which is a function of tau. This is Roman letter 2. From Roman letter 1 and 2, x of t is a wide and stationary. Now to find the power spectral density, Sxx of omega, which is equal to Fourier transform of Rxx of tau, which is equal to minus infinite to plus infinite Rxx of tau e power minus I omega tau d tau. From Roman letter 2, we can replace Rxx of tau by sigma square cos alpha tau into e power minus I omega tau. We know cos alpha tau which is equal to e power I alpha tau plus e power minus I alpha tau by 2. This is a formula in terms of expectation, cos in terms of expectation. So replacing that in cos alpha tau by e power I alpha tau plus e power minus I alpha tau by 2 into e power minus I omega tau. So next integral sigma square. 2 is a constant, 1 by 2 is a constant, take it outside from the integral, sigma square by 2 integral minus infinite to plus infinite e power I alpha t e power minus I omega t. We are separating the integral in 2 plus second integral sigma square by 2 integral minus infinite to plus infinite e power minus I alpha t e power minus I omega tau into d tau. So grouping e powers, taking minus I and tau outside. So first integrand become e power minus I omega minus alpha into tau d tau. Second integrand become e power minus I alpha plus omega tau. We know del function is equal to del omega is equal to 1 by 2 pi integral minus infinite to plus infinite e power I omega tau. Instead of omega in the first integral, you are having omega minus alpha. So replacing those things, sigma square by 2 pi del omega minus a. The second integral, instead of omega, you are having alpha plus omega. So sigma square 2 pi del omega plus alpha. So sigma square by 2 is common, take it outside. Sigma square by 2 into 2 pi also common, take it outside. Del omega minus alpha plus del omega plus alpha. 2 and 2 cancel, you will get PSD, power spectral density Sxx of omega, which is equal to sigma square pi del omega minus alpha plus del omega plus alpha. Thank you. We'll see in the next video.